Go ahead and write the definition of the word power. That's the first word there. It says write it. Oh shoot, I didn't even pass this out. Oh my gosh, coffee hasn't kicked in. My bad. As you get this, the first word is power. Write that definition. It's a base and an exponent. A base and an exponent. Go and copy that down. A base and an exponent. Please write that down. That's the first word. Second word, very straightforward definition. The second word is a number, or the number a base is raised to. The number a base is raised to. The number a base is raised to. The third word is base. A number or variable that is raised to an exponent. A lot of different words here. With one example, we're going to specify exactly what's going on here. Just write the definitions down and they're going to become clear right now with one example. All right. Now with one example, check this out. All three words are kind of related to each other, but with one example, I'm going to clear up the confusion. Watch this. In this little empty space underneath power, go to write q to the 8th power. Go to write q to the 8th. A variable raised to the 8th power. Write that down. Now, ignoring the first word, power, let's go to the second word real quick. Exponent. The number a base is raised to. So with the word exponent, go ahead and draw an arrow from the word exponent to the number 8. That's called the exponent. And you kind of already know that. And look at the third word, base. A number or variable that is raised to an exponent. So from the word base, go ahead and draw an arrow and point it at the q. That's the base, you see. And now let's go to the first word. Power is a base and an exponent. So the whole dang thing, look at it, put a box around everything. This is the power. It's the base with the exponent is called a power. So three words there, it's all right there. So base, exponent together is a power. Okay? Don't write this down. Let me do one more example here. Don't write this example down. Let's put w to the 50th power. Let's see if we're understanding this. What would be the base here? W would be the base. See, this is the base. Don't write this down. I just want to review what we just went over. What would be the power? 50? Close. Look at the words. The whole thing. Look at it. This would be the power, both the base and the exponent. And then this is the exponent. Okay? So the whole thing is a power. Both base and exponent is a power. Okay? So we got the individual items plus with the whole thing. Okay, cool. So we got to know what we got to be speaking the same language. When I use these words power, exponent, and base, you got to know what I'm talking about. Now here we go. We're going to get right into our rules now. I'm going to throw 7 rules at you that involve exponents. Okay? And these rules will enable you to simplify nasty, nasty, horrific-looking, horrifyingly, spectacularly horrifying expressions that have nasty exponents. These rules will enable you to simplify them and deal with them and handle them and manipulate them. first rule is this, and you can see it on your note guide right there. The first rule is called, underneath core concepts, you can see it. It's called a zero exponent. What do we do with an exponent of 0? That's what this rule is talking about. Go ahead and put a little cloud around this first example. Draw a little cloud around that first example. Underline the rule here. For any non-zero number, a to the 0 power is 1. A non-zero number. So for any non-zero number, if it's raised to the 0 power, it's going to be 1. Okay? So, what would be an example of a non-zero number, Estrada? What is a non-zero number? Can you think of a non-zero number? Thank you. How many are there in the universe that are not zero? Right. So there's an infinite amount of non-zero numbers. How many numbers are not non-zero? How many numbers are not non-zero? Go ahead. How many numbers are not non-zero? There's one. What number is it? 0. 0 is not non-zero. 0 is 0. So any number that's not 0, if it's raised to the 0 power, it's going to be 1. So underneath here on your sheet or off to the side, you have some space for notes. Go ahead and put EX, for example. Let me give you another example. Their example, we just put it in a cloud. Look at 4 to the 0 power is 1. It also works for negative numbers. Look at negative 4 to the 0 power. It's going to be 1. Why is that the case? Well, I'll explain later. Just for now, write it down. And just trust me. The question as to why, just put that in the back burner for now. So any number to the 0 power is 1 except 0. This works for any non-zero number. For instance, how about a fraction? How about 1/3 to the 0 power? 1. That's exactly what to look at. For any non-zero number, a, so a represents any non-zero number, a to the 0 power is going to be 1. Except for the 0. And look at, if 0 is to the 0 power, it's undefined. Maybe mark that on your notes there. It's already there on your notes. You can. Okay, so that's the first rule of exponents. You come across an exponent that's 0, it's going to be 1 unless the number's 0, unless the base is 0. So far, so good. Pretty straightforward, I trust. Let's do it. Next rule, right underneath that, is called negative exponents. What do you do with a negative exponent? That's funky and weird. You guys are not used to that. You come across an exponent that's negative, well, here's what you do. Check it out. For any integer is just a whole number. So put a little arrow on integer and put in parentheses. Integers are negative whole numbers, like negative 1, 0, and positive 1. So just whole numbers are either negative or positive and 0. If you don't know what an integer means. You should know what an integer means, but if you forgot, you might want to put a little parenthesis. Just to remind you of what an integer is. They're just whole numbers that are either negative or positive, including 0. So for any integer, n, so n represents some integer. Here's a rule. Here's a rule for all time. For any integer n and any non-zero number a to the negative n power is a reciprocal of a to the positive n power. Huh? Well, look at the example. Put a little cloud on the example here. We're going to put clouds on every example they give us. 4 to the negative 2 power is the reciprocal. Remember, that's a junior high word when you flip a fraction? No, no, no. Hold that. Let's see. Hold that question until I do one more example. Well, look at. So there's a negative exponent. What did they do? They took the reciprocal. So because this is all over 1, so they reciprocated it. You flip the numerator denominator and made the exponent positive. That's it. You flip it and make the exponent positive. That's all you do. Nothing more, nothing less. Done. Don't overthink this. Don't get all wacky and crazy and stressed out. If you have a negative exponent, flip it and make the exponent positive. That's all you do. Let me give you another example. Put this on where it says notes here. Put EX. Beltran, what's your favorite letter? R to the negative 8th power. Good. Because this is really over 1, right? We don't have to bother to write over 1 because every number is over 1. Right? This is really R to the negative 8 over 1. But that's not, we're professionals, so we know that this is all over 1. We know that's the case. So what would be the reciprocal of that? That would be 1 over R to the positive 8th power, and we're done. That's it. You just take the reciprocal and make the exponent positive. That's all you do. Or what? Go ahead. Go ahead and give me the question. What was it? A non-zero, yeah. So A cannot be 0. This only works for any number that's not 0. If you add 0 to a negative power, it's undefined. It's undefined. Here's another example. What do you have? Acevedo, what's your favorite letter? What if you have 1 over A to the negative 7th? One over A to the negative 7th. Let's do the reciprocal first. What would be the reciprocal of 1 over A to the negative 7th? Right, so you tip the denominator becomes the numerator. So look at A to the positive 7th over 1. And we're done, A to the 7th. So it's just A to the 7th. So you take the reciprocal and make the exponent positive. Nothing more, nothing less. I don't know what else to tell you guys. Come on. By the way, we're professionals in here, like I said, which is why I wear a tie. You don't have to put over 1. It's more professional to put A to the 7th because over the 1 denominator is always understood to be there, so it's not needed to write. It's more professional not to write over 1. So it's just A to the 7th. That's negative exponents. We got 0 exponent, we got negative exponent. Now here, flip the page. Look at the third rule. Product of powers property. Let A be a real number, and let M and N be integers. To multiply powers with the same base, add their exponents. To multiply powers with the same base, add their exponents. Let's put a cloud here. Put the cloud on this little example they gave us. So wherever you see the clouds, there's a straightforward example of the rule. I don't know if this is going to last the whole quarter here. Estrada and Beltran. I'm having my doubts here. Let's see. 4 to the 6th times 4 to the 3rd. Do these have the same base? Yeah, what is the base here? 4. Notice how we're multiplying and we have the same base. That's key. So look at to multiply powers with the same base. Underline that puppy. If we're multiplying and you have the same base, all you got to do is add the dang exponents. Look at 4 to the 6th times 4 to the 3rd is just 4 to the 6 plus 3 power. 6 plus 3 is 9. Done. Easy. That's all you do. This only works though for same base, mind you. Okay. Give another example. Z to the 10th power times Z to the 3rd power. We kind of already know this rule, huh? When we did expressions last week. Do these have the same base? Yes. Z. They both have Z, so let's just follow the rule. Just add the exponent, Z to the 13th power. How about, let's do one more. How about J, welcome Thomas. How about J to the, 1 second here. How about J to the 8th times J to the negative 6th power? Do those have the same base? Do those have the same base, Perez? What's the base there? J. So let's go ahead and apply the rule. Well, what does the rule say? Same base. What do you do with the exponents? Add them. So what would be 8 plus negative 6? So what's the stars? They weren't able to get the internet.
Okay.
I don't know what's going on.
All right. It's possible that they didn't get the patch from a few weeks ago.
Yeah.
So let me just look into it.
Awesome. Thank you so much. So what is 8 plus negative 6? You're awesome. Done. No, I mean, is that really that bad? I mean, come on. Same base, you're multiplying, add the exponents. Come on, that's it. Relax. Not a big deal. Last one for today. By the way, before we go to the last one, you guys remember from junior high what the word product means? What operation does product mean? What operation? Does it mean adding, subtracting, multiplying, or dividing? It means multiplying. So go ahead and put a little multiplication symbol next to product. This is when you're multiplying. Now compare that. Look at the title of the next rule. Check this out. Quotient. Nice. That's division. So what if we're dividing two terms with the same base? Now what do we do? Let's put a little cloud on the examples here. Okay, so the only thing that differs from the previous rule is that we're dividing now, but the same base. Same thing, it's just we're just dividing, but the same base. What do we do with the exponents? Look what it tells you. Just subtract them. And look at the example. 4 to the 6 divided by 4 to the 3rd is equal to 4 to the 6 minus 3. Right? We're on the second page here. On the next rule there. Just follow along. Add to it. Right, you just subtract them. So 6 minus 3 is 3. So 4 to the 3rd power. Just 4 to the 3rd power. Let's do another example. Do it with me. Here we go. Let's see. About G to the 10th divided by G to the 6th. Beltran, are these the same base? What is the base? G. So we're dividing, the rule says, subtract the exponents, we're good to go. So this will actually be G to the 10 minus 6 power, right? So it's G to the 4th. Okay? Let's do the last one just for giggles here. Let's go H to the 30th divided by h to the negative sixth. Little curveball. You could, or you could just follow the rule. Somebody help me. What would it be? Close. Help Castro out, somebody. So the rule says, by the way, Castro, do we have the same base here? Yeah, h, we're dividing. So somebody help Castro. She said h to the 24th. Help. I'm sorry? Good try. Somebody help Castro. Someone come to the rescue, please. So what would that be? Valero just came in. He's balling it up. What? Hit it. What is it? The 36 power. How'd you get 36? So, okay, so look at, if we're going to follow the rule strictly, we have same base. The rule says subtract the exponent. So let's see. This will be h to the 30 minus negative 6 power. You guys with me? Valero, coming up. Haven't seen you in a while, and you're sharp. How we doing? Thank you so much, Mr. Thomas. Appreciate that so much. So, like Valero said, minusing the negative is going to be a plus, so it'll be h to the 36 power. So you got to be careful. Follow the rule logically, specifically. It says to subtract the exponents, subtract them. It's going to be a 30 minus a negative 6. I think there's 3 more rules right there on your paper, right? There's 3 of them? Okay, we're going to hit those rules tomorrow. I don't want to throw too much at you because you might have nightmares tonight. I want you to get some sleep. So in the meantime, for the next 15 minutes, you're going to continue with assignment 22 from last week. If you're done with 22, go to Big Ideas and join my new class. Actually, this is not it. I got to put the class code here. Take about a minute for your social media if you want, and then go grab your Chromebook and start working on your next assignments.